I'm going to build a quadrifilar helical antenna. Say that three times real fast, huh? One of these. Specifically, we'll be building this antenna to pick up NOAA or NOAA satellite weather images using a software-defined radio on the computer. So let's get right into it. Hey there, we're back up, got Skycam set up. So the plans I'm using, and I'll post a link to these down in the description below. I'll post a link to this article that I'm building the antenna from. But the plans I'm using, all the measurements are metric. So I want to talk about that for a minute because I come from a part of the country here in Motown, the Motor City, Detroit, Big D, where we don't use the metric system. So I had to dig through and find some measuring instruments that are actually have metric on them, and I had this guy who goes to about 500 millimeters, which was handy but not nearly long enough for the lengths involved. So my US edition tape measure only has feet and inches, so that didn't do me much good either. So we're going to put that away. I had to go out and buy myself a metric tape measure. It's an 8-meter metric tape measure. So that was fun. We're dealing with lengths here of about 1,000 millimeters, which is a meter, but we're also dealing with increments of a single millimeter. So we're dealing with 903 millimeters and 1,002 millimeters. So I didn't really want to try to convert that to feet and inches and have that inaccuracy involved with that. I thought the accuracy of the using millimeters in the metric system and actually measuring these out in the system that they were designed in would be better. So a few dollars and I got myself a brand new metric tape measure. So some supplies I've got to build this. We've got an 1.25 inch piece of PVC pipe. It's cut to 1.5 meters already. I've already made that cut. And I've got myself, this is where I'm deviating a little bit from the plans here. The plans say to use, let's see, what they wanted 8 millimeter, which is 3/8 soft bore copper tube, and 8 copper elbows for the corner is what they're calling for. Well, my local home improvement store sold that size soft bore copper tubing, but they didn't sell corresponding elbows to go with it. And I looked and looked and looked, and I couldn't come up with a good way to attach the two pieces together in a 90-degree angle that was going to be, decent for what I thought would work. And this antenna that they designed here is made to go outside. I'm not going to be able to put this antenna outside. Mine's going to be indoors. It's going to sit in my attic, hopefully. So I went a different way. I went over to the electrical section and bought 20 feet of, what is this? Oh, it doesn't say what size it is. I believe it's number 6 copper wire, which is quite rigid. It takes a lot to bend this wire. I don't know if you can see. I'm putting a lot of force on this to try to bend it. Putting a whole lot of force on it. It's very difficult to bend, so it's quite rigid. I'm suspecting this is going to be adequately strong to maintain its shape indoors, where we're not dealing with wind load and things falling on it and such. And it should be left alone pretty well. There won't be animals or birds or anything trying to get on it. So this was fairly inexpensive. It was, I think, 45 cents. Yeah, it's 44 cents a foot. So we're talking about, under $9 for this and a couple dollars a piece of pipe. And that's a pretty inexpensive antenna. So first things first, I think we're going to lay out the pipe. We're going to take the pipe and lay it out, and then we'll cut the wire to size and start assembling. So let's go ahead and get with the pipe cutting. So the pipe laying out. It's already been cut. So all right, had to find some tools. I'm back now. Had to get my center finder and a small square, and I'm not really sure how we're gonna do this yet, but we'll figure this out as we go. So yeah, let's have a look at what we got here. millimeter holes at least 90 degrees to each other. 25 millimeters from the end of the mast. So, first measurement is 25 millimeters. 25. This is 1025. I've never actually measured like this quite before. So, let's double check that our cap is going to fit. No, see our cap. Oh dear, our cap is 35, so let's go 40 millimeters down. This is not so important. Well, we've got to be able to work on it though. So maybe that's going to be okay. We'll just attach the cap 2.5. That'll work. Okay. That'll be fine. It will be fine. Alright. So here's what we're going to do. Here's what we're going to do. I'm not sure if you'll be able to see this end. Yeah, I guess you can see the end. Let me adjust Skycam a little bit here so you can see what I'm working on here in the end. What we're going to do is come to the edge here and grab a clamp down, and we're going to square. I need a better square here. This is not going to work. Take this little block, and I think if we check this for square, it is quite square. So we're going to use this little block to square this to the table. There, hopefully that's going to hold it square enough for us to do what we need to do next, which is, what are we doing next? We're going to mark at 2.5 millimeters. We're going to mark this guy like this. Okay, and then let's see our dimensions. We're going to come down 900 millimeters. And we're going to mark it again down in this neighborhood. So now I've got a line here and a line here that are down at this end. I've got two lines now that are in the same plane. Granted, it's not where my lines are here, so these lines are going to be meaningless for a moment because it's not going to work out that way, but that's okay. What we're going to do is turn this 90 degrees and do the same thing to our other two lines. We're going to square to those. Okay, and now we're going to do the same exact process here. So this line will be 90 degrees around from this line. Now we need to go down 1,000. If I'm far enough down the table here, this is going to be a short. Okay, it is 1,000. Right to the end. So I got to go right off the end of the table here. Let's reorientate Skycam here so you can see the whole table again. Now that we're done with that end. Alright. So, now what we've got to do is mark on these lines. We've got to mark 25 millimeters. And this is the long one, I believe, or the short one. This is the short one, so we got to go down 900 millimeters from that. So we're doing 925 millimeters from the end of the pipe. There we go. Now we turn it to 90 degrees, and we're going to mark 1,025 here and 25 up here. There we go. So that's our layout of the pipe. So the top holes will be in the same section here, right? Same length. Then we'll have one set of holes that goes down 900 millimeters from there, and then this other set, which is 90 degrees off from that, will go down 1,000 millimeters. So yeah, that's our drilling plan. All right, so let's measure this wire here. It is almost dead on 1/8 of an inch. That is so stinking close to 1/8 of an inch that we're going to go with 1/8 of an inch. Let's start off our adventure with a smaller drill bit here. Start off our adventure with a little tiny drill bit. It's a good starter hole though. Let's go with the next size up that I've got in the kit. We're going to have to just do the best we can here. This is not a perfect world. In a perfect world, we would have marked the other side and drilled through that, and then we drill through here, and maybe drill all the way through, make sure they all lined up, and then we'd be nice and square. But given the imperfect nature of our world that we live in, and the fact this is a receive-only antenna, we're just going to go ahead and wing it. And it's as good as it's going to get. I'm sorry. If you wanted professional work, you'd hire a professional, right? Let's test fit our wire now that we've made all these holes. Oh, that is too tight. That is actually perfect. I take that back. That's not too tight. That is snug as can be. I think it's perfect. All right, we are going to set the mast, the pipe here aside for now. Put it over here. Not that you can see where over here is, because you're on Skycam. So let's take to measuring the pieces of wire now. Everything. Oh, the dog wants to be in the movie. Dog wants to be in the movie. Must be somebody walking by outside. Heaven forbid. All right, 190 millimeters. Let's just do this. Let's extend the tape out here. Lock it into position. And go to 100. Well, see, let's think about this for a second. This was designed so that we had elbows in place, and this is supposed to be 200 millimeters apart, and 190 millimeters is assuming 10 millimeters worth of elbows, which we don't have 10 millimeters worth of elbows. We've got about 4 millimeters worth of wire. So instead of making this 190 millimeters, I'm going to make it 196 millimeters. see, so this should go to perfect. Okay, we'll make another one just like that. And then we gotta go let the dog out, because I don't know if you can hear her, but she's at the back door making a fuss. So, alright, next up. 2 at 903 millimeters. So, this is designed for 10 millimeter. So I'm going to add 10 millimeters to that. I can always cut it off. Let's just add it. And we can always cut it off. Better to cut it too long now. So I need 913. 913. $1,002, so we're going to go 1,012. At 90. So this, let's think this through. We've added 10 millimeters to each of these full lengths. So these are 90, and 90 is 180. So if we added 10, we'd get 190. So let's take that in half. That's going to be 95 millimeters. Let's go 95 millimeters. Good news is I bought enough wire. Alright, so we need a balun, we need to drill a hole, we need to make the balun. So let's grab, probably want to do that first. I'm cheating. I'm going to use this piece of coax here. I'm going to cut the end off of it, and I'm going to use it for the feed line. I'm just going to cut the end off of it and not look back. Take that, toss it. Alright, so we need to get a drill bit this will fit through. Let's measure it real quick. It is 3/16. So we will drill a 3/16 hole. Grab our mast or post here. And we'll come down somewhere about here, I think. So let's drill a small hole again. Let's test fit our piece of coax. And it is a bit too tight. So let's go to 13/64, which is the next drill bit I have. I think this one's going to work. I think we just got to get it in there. Yep, it's going to work. Okay, so let's see if we can't feed this up. Because I might mess this up a couple of times, I don't know. I've been down this road before. So we got the shield twisted up here. Pull the foil off and get it out of the way. We get the shield off to one side. We get the center conductor off to the other side. And it's stranded. That's interesting. Suppose that makes it more flexible, huh? You're in the picture, you're in the movie, it's in the movie, good, you're in the picture. So what we can do is start to shove these guys into here. You're supposed to be 200 millimeters, less 8. This is the short loop up here, so let's do this. Let's say this is an S, and this is an L, right? That's the long loop. That's the short loop. Okay, so this is, wait, this is the short loop. No, I got that wrong, because this is the long piece, but it twists 90 degrees. Okay, good catch. Got the beefy iron out. I'm gonna pull this guy back up and do this. I'm gonna strip some more off, and I'm gonna use these conductors. Strip some more off of here and use the conductors to go from one to the other. Alright, let's see if we can't get that up where you can see what we've got there. So this is a long wire, short wire, long down on the bottom there, and short. And you can see how they're connected from the long it's at the ground. That's the shield. Comes from the coax to the long and over to the short, and then the center conductor comes from the coax to the long and then over to the short. That's what the plans call for. Now, let's wrap our balun. Wrap the coax 4 times around the mast and tape. Let's see if we can find some tape. All right. One, 2, 3, 4. This doesn't have to be weatherproof. This is just holding it in place so it doesn't move. Let's get our longer wires, shove them through these holes. Now, these are the short wires here. Now, how do we go about soldering these on there? That is a fine question that I have not yet figured out an answer to. Let's first of all put our... So, this short one's got to go from here to here, so it's got to go here. So I got to solder that on there. How are we going to hold that? How are we going to hold that? Cannot get enough heat on that with that little soldering iron. So, who's next? Next is we're almost out of battery. There. We might have it. We might have it now. At this point, I'm just trying to get the solder joints done, and I will adjust the shape after. got to adjust everything a little bit. Hit the ceiling. Try it out. See what she does. Just got to bend things a little. Get them so it's a little bit more helical. So that right there is the antenna.